Hello everyone, this is Paul. Welcome to the ODE assignment discussion. In this assignment, we have 8 problems, and the last one is not required for is not required for let's begin with the first one. In the first assignment, you're asked to develop a function named the ODE solver. So let's look at this function declaration. So we have 4 input arguments, which are f function and t-span, excuse me, t-span and initial condition and solver type. So function handle is a handle to a function defining the derivative, and t-span is 1 by n vector here. If n is 2, it means the first element is the start time, and the second element is the end time. And if n is bigger than 2, it means all the result will return estimate solution to at these points. Initial condition is k by 1 vector. Here k is the order of the ODE, and the solver type is ODE 23 and ODE 45. So if it is ODE 23, you just give 23, and ODE 45, you just give 45. The output arguments are t point and y. T point is separate time points at which the solver returns the solution, and y is corresponding solutions. So there is some hint for this problem. The solver type tells you which the built-in function to call, the ODE 23 or ODE 45. You may use a switch or if condition to choose the ODE type, and the other 3 input arguments will be provided as input arguments of ODE 23 or ODE 45. That's all for the first problem. And the second problem is it's asking you to define a function with no input argument. The function is the purpose of the function is to give a function handle t-span, time span, and initial condition, and flag. Flag is the ODE type. So its name is P2 setup. In this assignment, the ODE solver, which we built in problem 1, will be used several times. So if in problem 2 we get the function handle, time span, and initial condition and ODE type, we can use these 4 output arguments as the input arguments of the ODE solver then we can solve the y values and the t points. So be careful, there is no input argument, and the output arguments, the fh is a function handle. So in this function, you probably need to define an anonymous function. Time span is time span is the starting and ending points. So in this problem, it is 0 and 10, and the ODE type is 23. This is for problem 2. For problem 3, you are asked to define another ODE function. ODE. In this problem, the same thing. There is no input arguments, and there's only two differences between problem 2. The first one is the first derivative of y. It is not cosine x anymore. It is minus y. So your function handle should be different. When you define the function handle, you probably need to announce the variables. In this case, both x and y will be the variables, but sometimes, for example, in the problem 2, it is cosine x. It is the time derivative is about x. Expression is about x, and in this problem 3, it is about y. And in problem 3, you are asked to use ODE 45 to solve this problem. Problem 4 is a little difficult, because it is second order ODE. You can see you have y double prime, which means the second differential equation of y. So for higher order ODE, we need to recast the problem into system one order ODE. The idea may be introduced in the videos by professor. In this problem, we have something expression y partial plus y partial and plus y equals to sine x. So we need to analyze this differential equation and build a system of two one order ODE. So the independent variable is x. And dependent variable is y. Y has two variables. One is y itself. The other is Probably I use capital Y here. The other is Y prime. And so Y capital Y prime equals to Y prime and Y double prime. So if we replace this Y prime with the element of capital Y, it should be Y, the first element, and the Y double prime it is can be expressed in terms of capital Y. So your work is to find the expression of Y double prime in terms of this capital Y. So how to do that? You just need to replace the Y prime with Y capital Y1 in the equation provided. Say this equation. And replace Y with capital Y1. So in that case, you can find Y prime in terms of Y1 and Y2. So that you can build the two functions. Then you assign these two functions to function handle as an output. The form of the function handle is something like this. Function 1 and function 2, it is a function array. In this problem, the t-span will now change, and the initial condition, you have to provide two initial values. One is for y, and the other is for y prime. The flag is ODE 23. This is for problem 4. And for problem 5, it is about a heat transfer problem in which we have a second order differential equation. For second order differential equation, the first thing we need to do is recast them into system of first order differential equation. Let's look at the independent variable. In this problem, it is x. It is one-dimensional space x, which represent the position. And the dependent variables, we name it small t. Small t is small t consists of T, the temperature at different position, and T prime, which is the temperature change along X. So we can find that the T prime equals to capital T prime and capital T double prime. Capital T prime is just the first element of small t, and the capital T double prime is we can find its expression in terms of small t1 and small t2 by analyzing the equation. The process is same as the last the problem 4. We just replace tx with small t1, and we can find the expression of capital T double prime in terms of small t. For this problem, we have two cases. The first case is named initial condition problem, which means T0 and T prime 0 are given. After we got the expression, small t prime, which is a function handle, we can put this function handle to the ODE 45 or ODE 23 to solve this problem. We can find the t at different x point. So it's not difficult for case 1, but in case 2, what is in case 2, what is given is T at the x equals to 0 and temperature at x equals to 10. It becomes boundary value problem. So as the T prime at x equals to 0 is not given, we cannot directly do integration to get all the temperature at different points. What we can do is we define a function which is named get10. The input argument is p, which is the t prime at x equals to 0, which is not known. So in function get10, it is pretty similar as we define the function handle to solve the ODE problem. The P is, although we don't know the temperature, T prime at x equals 0, but we can define it as a variable. So in that case, it is given as a variable. So we put this variable into the function handle. We can get an expression of temperature at a different point. Then we call this function in another M file, which is h8, the variable. So it is an anonymous function, and the output of this anonymous function is the temperature at x equals to 10. What we should do is give an initial guess and use f0 function to solve this problem. So in the f0, the first input argument is h, which is the function handle, and the second input argument is initial guess. So just to follow the words in the assignment, I think you can easily get this function done. This is for problem 5. Problem 6 is a control problem which is very complicated. So I decided to first talk about the problem 7. Then we go back to talk about this problem 6. Problem 7 is the idea is also very simple. It is a problem about a double pendulum. So in this double pendulum problem, the time is an independent variable, and the dependent variable, we name it x. So x consists of theta and theta prime and a beta prime. Beta prime is a time derivative of theta, and beta prime is time derivative of beta. And so x prime, we can express it as theta prime and theta double prime, beta prime and beta double prime. If we replace theta prime with x2 and beta prime with x4, then we two expression about theta double prime and beta double prime are provided in the assignment PDF. If we replace the beta prime and theta prime with x1, not x1, x2, and x4, we can find the expression of beta double prime and theta double prime in terms of x2 and x4. Also, I think x1 and x3 will included in the expression. The same thing is you need to define x prime function, which is also a function array. It is 1 by 4. We have 4 functions. We also have case 1 and case 2, but the only difference between these two cases are just the initial conditions, just the value of theta, theta prime, and beta prime. So what you need to do is just to change the initial condition and put the function handle, initial condition, and the time span into the ODE solver, you can get the theta and the beta at a different time, which describe the motion of the pendulum. Okay, after problem 7, let's go back to the problem 6. Problem 6 is about cruise control. It is a control problem. You probably need to read the introduction part carefully. There are many variables mentioned here. And first of all, let's briefly go over the logic. So a cruise control system consists of 3 models. The first model is the car model. In which the input is throttle angle, UT, and the road grade. DT. The output are acceleration, YT. There are 2 equations provided in the assignment to describe their relationship. So here the M is probably the mass of the car, and the U prime is just the time derivative of the throttle angle. And the alpha E, capital E, and G are just a constant. And the Y is the acceleration. Y is just the velocity of the car, and the Y prime is the acceleration. It means if we know the throttle angle and the road grade, we can calculate the acceleration of the car. This is the first model, and the second model is the filter model. The input is the car's speed measured by a sensor. We name it YMT. And the output is filtered car speed measurement. It is YFT. Here we have another variable, sigma. Sigma is just the filtered car speed measurement. It is the same thing as YF. But sigma prime has a relationship between the sigma and the YM. The one after the measurement by the sensor, there is sometimes there is some noise. So the filter's function is to filter the noise and get the real speed. The last model is a control strategy. In the control strategy, the input is YFT, and YFT is just the output of the filter model, which is the speed of the car, and RT. Another input is RT. RT is the desired speed, which also called reference. So the measured speed, after filtering, the filtered measured speed is sometimes it is different from the desired speed. So we need to control the throat angle to increase the speed or decrease the speed to let it reach the desired speed. So the equations about the throttle angle is the following equations. In these two equations, Ki, K1, and K2 are just provided constant. And the UT is the output throttle angle. These are the three models for this control problem. Then we try to describe the problem by develop several differential equations. So in step 2, we try to find some of the ODE system of this problem. So in this problem, we care about the acceleration, the speed, the sigma t, and the psi t. Psi t is about the throat angle, and sigma t is about how the filter works. So this F1, F2, F3 are expressions of these three derivative variables in terms of the Vt, which is the speed, and sigma t, psi t, Rt is the designed speed, and D is the road grade, and Nt is just the noise. So the expression of function 1, function 2, and function 3 can be found in the page 6 in the assignment. Then we need to, we can find that from page 6 to page 7, each model built by the equations. We have some functions fg and hg, ff, hf, fk, and hk. You probably need to build these expressions yourself. Just use the equations provided in the model and choose right variables, and then you can find the expression of another 6 variables. Here, these 6 these six functions are function handles. So be careful here. After you have the model being built, then you can try to build a function to solve the model. So in step 3, we are going to build the function IC3 connect. I will give the pseudo code here. So in the IC3 connect, you first, because you have this x is just x is defined in the assignment as the speed, and it is a 3x1 vector, consists of the speed, the sigma, and the psi. So these are three variables we want to know at different time. R, D, and N are three. R is a vector describing the desired speed at different time, and D here gives the information about the road grade, and this N is contains some information about the noise. And with these input arguments and the function handle, we can find the expression of the acceleration and the sigma prime and psi prime. So just use the 6 function handle here to build the output of this function. Be careful here, x dot is a vector output. It contains the x prime, the z prime, and sigma prime, and psi prime. After this step, we are going to look at the application of this this model. So in the problem B, we are asked to simulate the interconnection for a certain group of input and initial conditions. We have RT defined and the DT defined. So for this condition, RT and DT should be a vector. It contains these two vectors contain the same element with the T data. T data is the time data. And some code are provided in the assignment to make the noise function. So you just follow the code, you can get the NT also. With this with R, D, and N given, so you can then use ODE, maybe ODE 45 to solve this model. So be careful here. This is the declaration, not the declaration. This is how I call the ODE 45. And this R, D, and N are vectors as input argument. So these three variables will not be the changing variable. The only changing variable is x here, which is a 3 by 1 vector. And after the in the ODE 45 sentence, in the parentheses, after calling the function, you need to provide the time data. That is the initial value of x. To get the initial value, you probably need to define all the constant very well. In the assignment, just the velocity at time equals to 0 is given, and the sigma 0 is equals to the velocity, and the sine 0 is should be calculated through the equation given. So this is for the cruise control system problem. And also we have problem 8. As I mentioned, this problem is not required, but it is very interesting, and you can find the two website here talking about this sport. And what you need to do in this question, what you can do in this problem is just read the introduction and then try to understand how it works. At the end, you can find probably you can download the log robot derived function from the website. Then you can run this function by using ODE 45 and get a brief idea about how this robot works. Well, this is all for this ODE assignment. This assignment is pretty long, so you probably need to